Hello everyone. Topic is oxidation of 2-degree alcohol by potassium permanganate in acidic medium. Its mechanism we will understand. Yesterday we have covered 1-degree alcohol reacting with KMnO4, its mechanism. Now this one. Not for 12th class, involved in JEE advanced and B.Sc level. 2-degree alcohol reacting with strong oxidizing agent KMnO4 firstly will create ketone. That ketone can be further oxidized to carboxylic acid, alcohol. These alcohols can be easily oxidized by strong oxidizing agents to aldehyde, and these aldehydes can be also oxidized further to carboxylic acid. If this carboxylic acid contains one carbon, so it will be oxidized to CO2 plus H2O. In yesterday video, I have told you. But more than one carbons are there, so further oxidation of carboxylic acid will not happen. Now let's understand its mechanism. For that, I am using a 2-degree alcohol. This one, KMnO4. Yesterday I also told you how KMnO4 is working. It's an ionic compound like this. This Mn, manganese Mn, it's a tetrahedrally surrounded by 4 oxygens. Charge is +7, positive +7, because it is sharing 7 electrons with oxygen, which are highly electronegative. So these 7 electrons are going partially toward oxygen. That's why it is carrying +7 charge. Due to this strong positive charge, it have a tendency to attract electrons. Who can provide electrons to it? Oxygen of alcohol, because this oxygen is carrying lone pairs. Now these lone pairs will start attacking on Mn. Mn can make maximum 7 bonds. So obviously out of these 7, one bond will break, and that will be pi bond, because pi bonds are weak bonds. Suppose we are breaking this pi bond, electrons will completely shift toward oxygen because oxygen is more electronegative. So the next condition generated will be this. Because this oxygen is getting extra electron of manganese, that's why it is carrying extra -1 charge, and here only a single bond will left. Now because this oxygen is delivering lone pair to Mn, this is a dative bond. Out of 2 electron, 1 electron it is completely transferring toward Mn, and 1 it is keeping with itself. That's why it is carrying +1 charge. In this condition, this oxygen is highly unstable. What it will do? It will break bond from hydrogen. And obviously electrons will completely shift toward oxygen, and hydrogen will release out as H positive particle. And that H positive particle is electrophile, can easily gain electron from oxygen, these oxygens which are carrying negative charge, because these negatively charged oxygens are carrying 3 lone pairs. After this, new compound generated will be this. This one. This oxygen will become stable, and positive charge will finish out because it got extra electron from hydrogen side. This intermediate which is generated is known as manganese ester. Yesterday also it was generated when I was dealing with 1-degree alcohol mechanism, manganese ester. Now what this manganese ester is doing, let's check. As you can see in this manganese ester, lot of oxygens are available. They are strong attractive electron attracting groups. So these electrons of carbon and oxygen side, these bonded electrons are strongly going toward Mn side, because this Mn side contains lot of oxygen. Now, because this carbon is losing its electrons strongly, so it will start attracting electrons from its hydrogen strongly, due to which this hydrogen will become highly positive, or you can say it becomes acidic in nature, strongly acidic. Check this. This is the main point where manganese ester is working. This manganese ester contain lot of oxygens, so they are attracting electrons from carbon side. Because carbon is losing its electrons strongly, so it will start attracting electrons from hydrogen. I effect, minus I effect. Due to which hydrogen will become highly positive because it is losing its electron. Highly positive. Highly positive means strongly acidic. Now, on this strongly acidic hydrogen, base will attack, which will be provided by dilute conditions of sulfuric acid. In dilute sulfuric acid, water molecules are available in large amount, and water molecules always break in two parts, H positive, OH negative. This OH negative part will start attacking on these hydrogen. Between carbon and hydrogen bond will break and electrons will shift toward carbon. H positive, OH negative will combine to produce another molecule of H2O. Now these electrons which had gone toward carbon, these electrons will shift toward oxygen, because this side is strongly electron pulling group, strongly they are attracting electrons. So these electrons will go toward oxygen, and this will happen. This. Now, because this bond is getting formed between carbon and oxygen, oxygen is stable with two bonds. So this is a second bond. So obviously it have to break its bond from Mn side, and electrons will go toward Mn, because electrons are coming from carbon side. So these electrons will feel repulsion and they will go toward Mn, and between oxygen and Mn bond will break, due to which this compound will generate. It's a ketone, you can check. H is released out as H2O. Between oxygen and Mn bond will break, and this Mn will release out in this fashion with pair of electron. So you can check oxidation state of Mn here. 6 electrons it is sharing with oxygen, means plus 6, but it got one extra electron from oxygen side, so total charge will be plus 5. This one. Ketone is generated. Now this ketone will be further oxidized. Let's check how. So 2-degree alcohol firstly create ketone. This is a ketone which is generated here. Now ketones further oxidation will happen through the generation of enols. Remember, when aldehydes were generated during 1-degree alcohol oxidation, aldehydes were oxidized further by reacting with H2O, H positive, OH negatives, O negative, carbon was positive, it was attacked by OH negative. So hydrated aldehydes were generated. This one. These hydrated aldehydes were reacted further with KMnO4 to give final oxidizing product. But such reactions will not happen with ketone, because these reactions are nucleophilic addition reactions. Ketones are less reactive toward nucleophilic addition reaction as compared to aldehyde due to these two alkyl groups. When we will discuss aldehyde and ketones, there we will discuss it. So ketone is not going to show such type of hydrated ketones. Its oxidation will happen further with a different mechanism. Let's check what is that mechanism. Dilute H2SO4 which we are using will provide us positive particles, H positive. H positive are electrophile. Electrophiles need electron. Who can provide electrons? Oxygen. These pi electrons will shift completely toward oxygen for the bond formation with H, due to which this carbon will become carbocation because it is losing its one electron and vacant orbital will generate. Now this carbocation can be satisfied by these two carbons. These are alpha carbon. So suppose this carbon is satisfying this carbon. So what it will do, it will break bond from its hydrogen completely and will shift here, due to which this enol will generate. This is enol. En means double bond, ol means OH group is there, enol. And suppose this carbon is satisfying this carbocation by shifting its electron here. And obviously what will release out here? H positive, which was used. So if I am using this alpha carbon, so this enol will generate. This will remain as it is. So two enols are possible. Out of these two enols, this enol will be major and this will be minor. Reason, enol stability depends on hyperconjugation. Check. This en part is getting stability by, and hyperconjugation depends on alpha hydrogens. So here we have 1, 2. Two alpha hydrogens are there. So this is less stable as compared to this, where it is getting stability by how many hyperconjugations? 3 and 3. 6 alpha hydrogens are there. So this enol is more stable as compared to this enol. That's why it is major and this is minor. You can check. Please remember one rule I have told you while oxidation of ketone, Popov rule. I said break bond from bigger alkyl group side. This is the reason. From bigger alkyl group side, we are getting major enol, means more stable enol. And from smaller alkyl group side, you can check, we are getting enol which is less stable. That's why bond will break from bigger alkyl group side, means oxidation will happen and you will find out bond will break from here. This is the reason. So in this fashion, first ketones will convert itself to enol in the presence of acidic condition. Now these enols will get further oxidized. I am going to use this major enol. I am not using it. You can use it also. Same mechanism will be there. Apply it. But because it's a minor, less particles are there. So that's why I am not using. I am going for major enol particle. Now what will happen with this major enol particle? Let's check. How KMnO4 is going to oxidize it. Very easy mechanism. Another particle of MnO4 will come here. As you know, Mn is carrying +7 charge, wants electron. Who can provide electrons? Oxygen is there with lone pair, pi electrons are available. It will prefer to attack on pi electrons because pi electrons are weakly held by atoms and perpendicular to the molecule, which can be easily attacked by electrophile. And second point, lone pairs are on oxygen, which is a strong electronegative atom, not easily provide electron to Mn. So they will prefer this easy target. But these two electrons will not go directly to Mn. They will go indirectly. Look how. Suppose this carbon is near to this oxygen. So this oxygen will start attracting pi electrons, due to which these pi electrons will be pushed toward Mn. Check. This is indirect delivery of electrons. Due to which, what changes will arise? This carbon is losing its electron, so vacant orbital with a positive charge, H as it is. Single bond will be here because this bond is broken and it is generated with oxygen. Single bond between oxygen, this carbon will make bond with oxygen and these pi electrons will shift to Mn and here single bond will left. Now, in the neighbor of this oxygen, this carbon is present with a vacant orbital, positive charge. So obviously what this oxygen will do, it will break bond from Mn, pi bond, and will shift to this carbon, due to which between this carbon and this oxygen bond will generate, that I am going to draw. Like this. The positive charge of carbon will finish out. Now, this intermediate which is generated, it is known as cyclic manganese diester, because two ester bonds it has made, 1 2, so that's why we are calling it diester. And because it is a cyclic, so cyclic manganese diester. When 2-degree alcohol made ketone, one intermediate was generated, that was manganese ester, but it is manganese diester because two ester bonds are generated there, and it is cyclic, that's why we are calling it cyclic manganese diester. That's it. This is the main point. Now after this, what will happen, because you can check it's a cyclic condition, and due to steric hindrance, this bond will become weak and will start breaking. This is a cyclic condition due to which between these two carbons this bond will become weak and will start to break. Now how it will break? With two ways we have by which you can break it. Like, one way is this: these two electrons completely transfer toward this oxygen side, due to which this oxygen and Mn bond will break and electrons will shift toward Mn, and these electrons, because this carbon will get positive charge, vacant orbital, so this oxygen will deliver electrons to that side. Now when you will break it, you will find what is generated. Between this carbon and this oxygen, double bond will generate and this bond will break. OH as it is. Between this carbon and this oxygen, double bond will generate like this, and it will release out. Please check what particle will release out by yourself and check its oxidation state of Mn. Now focus on main particles which are generated here: aldehyde and carboxylic acid. Now carboxylic acid, because contains two carbon atom, will not get further oxidized by KMnO4. But this aldehyde we know can be further oxidized by KMnO4. What will happen with that? We know its mechanism. Yesterday I told you. It will first create hydrates with H2O. And these hydrates will react with KMnO4 particle and further oxidation will happen. That mechanism already yesterday we have discussed. You can check that video. That's it. This is the end of the video. In this fashion, with this mechanism, 2-degree alcohols are firstly creating ketone, and that ketone is further getting oxidized with the formation of enols first. And while forming enol, keep that point in your mind. Enol formed from highly substituted alkyl or bigger alkyl group side will be more stable as compared to smaller alkyl group side due to more hyperconjugation. That's it. Thank you very much. In next video, we will try to understand the mechanism of 3-degree alcohol oxidation. Thank you.